Hello everyone and welcome to this video on what is hierarchical clustering by Intellipaat. So hierarchical clustering is basically a group of data points that were put together in the form of clusters based on their similarities or the distance between those data points. And later on it gets visualized in the form of tree-like structure. So in our today's video, we are going to focus on this hierarchical clustering, how it actually works, and at last we will try to implement this using this scikit-learn library. But before we begin with this video, please subscribe to our Intellipaat YouTube channel so that you won't miss any updates coming from our side. Now let's move forward with our agenda for today's video. We will start with what is hierarchical clustering, then we will move forward and we will look into how hierarchical clustering actually works, and after that we will see what all types of hierarchical clusterings are present there, and at last we will see the implementation of hierarchical clustering. And with that, we will conclude our today's video on what is hierarchical clustering. I hope I have made myself clear with the agenda for today's video. Now let's start with our first topic, that is what is hierarchical clustering. So as I said you, hierarchical clustering is an unsupervised machine learning technique for grouping the similar data points into a hierarchy of clusters. And unlike any other clustering algorithm that gives you a single set of clusters, hierarchical clustering produces a tree-like structure where the clusters are nested within other clusters. And this allows you to explore the data at different levels, and you can decide where to cut the tree and get the desired number of clusters. And this hierarchical clustering is also known as hierarchical cluster analysis, or HCA. Now let us understand how actually this hierarchical clustering works. So we start with plotting the data points which were inside their individual clusters. Like you can see here, these are all the data points which were already inside their individual clusters, right? And then we will look into the distances between these data points or the similarities between these data points. And once we will get a minimum distance between any two data points, or we will get any similarities between the data points, we will form a cluster using that data points or that individual clusters. We will merge those individual clusters and form another cluster using those two individual data points. Like here you can see two blue data points that were already inside their individual clusters are having a minimum distance between them. So now these two individual clusters will merge and form a single cluster now. And now we have to find the next two clusters which were having a minimum distance between them or having some similar characteristics. Like these two data points, or I will say the individual clusters, are having a minimum distance between them, and now these two individuals will merge and form a cluster, right? And now again we will look for two other clusters that are having a minimum distance or having some similar characteristics, like this individual cluster and the cluster that were formed in our previous step. These two are having a minimum distance now, and now this will merge and form a new cluster here, right? And this step keeps on going until we get a single cluster from all of these individual data points. And we keep on iterating this. We'll form clusters, and using that clusters we will form the new clusters, and it's keep on iterating until we get a single cluster like this from these data points. And the aim of this hierarchical clustering is this, that we will form a single cluster using all of the data points or all the individual clusters. Now let us move forward and see what is Euclidean distance. So it is basically a straight line distance between the two data points in a space, and it is generally the shortest possible path between any two data points that were connecting them. So this Euclidean distance is basically used to find the distance between the two clusters. Like I have said in the example previously, that we have to find the distance between the two clusters, and we have to merge only those two clusters that are having a minimum distance between them. So here this Euclidean distance formula is used to find that minimum distance. And yes, there are many other techniques also to find that minimum distance, and Euclidean distance formula is one of them. So here below you can see the formula for Euclidean distance, and using that formula only you can find the minimum distance between any two clusters and take decision about which two clusters to merge next. Right. Now let us move forward. So next is the dendrogram. So dendrogram is basically the output of any hierarchical clustering. Or if I have to say it in a very simple way, this dendrogram shows and how that all individual clusters form a single cluster. So this dendrogram shows a clear picture of how these all individual clusters form a single cluster from that. So let us take our previous example and we'll see how our dendrogram looks for those example. So as we have seen in the previous example, and we know that the first cluster formation is of data points G and H, right? So this is the first cluster formation, and after that we have formed a cluster on points A and B, and after that we have formed our next cluster that is A, B and C, right? And then after we have formed our cluster F, G and H, right? So this is the same sequence or the same example that I have shown previously, right? And then we will form the cluster A, B, C, D, right? And then we will form our next cluster with A, B, C, D, E. And now we will form our final and the single cluster from all of these data points that look somewhat like this. And this is the dendrogram for the example that we have taken previously. And this is the output of hierarchical clustering for these individual data points. Now let us move forward and see the types of hierarchical clustering. So there are basically two types of hierarchical clustering that are present. One is agglomerative clustering and another one is divisive clustering. Now let us understand both of these clustering one by one. So the first that we will see is agglomerative clustering. So in this technique, initially each of the data points will be considered as individual clusters. And after each iteration, the similar clusters get merged with other clusters, and it's keep on iterating until we form one cluster or k clusters from those data points, right? So now talking about the basic algorithm of agglomerative clustering is that it is a very straightforward one. It starts with computing the proximity matrix. Then each data points become a cluster, and after that we will keep iterating this, merging the two closest clusters and updating the proximity matrix until we get a single cluster from that. So as we can see in the example here, in the initial step we will calculate the proximity of individual points and consider all the 6 data points as the individual clusters as shown in the image. And in step 2, similar clusters get merged together and form as a single cluster. Let's consider BC and DE are the similar clusters that are merged in step 2, as you can see in the image. Now we are left with 4 clusters, which are A, BC, DE and F. So we again calculate the proximity matrix of new clusters and merge the similar clusters to form a new clusters A, BC, DEF, and we keep on doing this until all clusters are merged together and form a single cluster. So as you can see in the image, at last we get formed a single cluster that is A, B, C, D, E, F. Right. Now let's move forward and we'll see our second type of hierarchical clustering, that is divisive clustering. Now in this technique we will consider all the data points as a single cluster, and in each iteration we will separate the data points from the cluster which are not similar. And as each data point which is separated, it will be considered as an individual cluster. And in the end, we will be left with n number of clusters. So as we are dividing the single clusters into n clusters, this technique got its name as divisive hierarchical clustering. So as you can see, the same example that I used to explain you about the agglomerative clustering, this divisive clustering is exactly opposite to the agglomerative clustering. Agglomerative clustering is a technique which comes top to bottom, whereas a divisive clustering is a technique which goes bottom to top. So as you can see in the image here, it starts with a cluster A, B, C, D, E, F. And on the next step, how a data point A gets separated from that cluster. So in this step, A gets separated because the data points A is having a little bit different characteristics to the data points that were present in that cluster. So as in the first step, you can see how data points A get separated from that cluster because A data point is having a little bit different characteristics to the other data points that were present in that cluster. And on the second step, how you can see B and C get separated and only left with DEF because BC is having a little bit different characteristics other than DEF. So in that way, it's keep on separating and it's keep on iterating until all the data points get into its individual clusters. And that's how the divisive clustering actually works, right? So as we have understood what is hierarchical clustering, how it actually works, we have seen the types of hierarchical clustering, that is divisive and agglomerative, how it actually works. Now let us see the implementation of hierarchical clustering using the scikit-learn library. Okay guys, now we are here at the Google Colab notebook, and here I have imported all of the necessary libraries that we needed for the implementation of hierarchical clustering. Like I have imported pandas here, and then I have imported matplotlib. So this will be useful for the plotting of scatter plot. Then I have imported iris dataset from sklearn. Then I have imported standard scalar. So this will be useful for the normalization of our data. Then I have imported here pdist and square form. So this will be useful to find the Euclidean distance between the data points. And then here I have imported linkage and dendrogram. So this will basically plot the dendrogram for the hierarchical clustering that we do on our data points, right? And after that, I have loaded our iris dataset here in the iris variable. And I also declared x and y and given the iris data and iris target to that x and y, right? Now let's start with creating a scatter plot for our iris dataset. So let's create the scatter plot for our iris dataset. So I will write here public figure, and I will give here the figure size first. Figure size, and I will give here 8,6. And then I have to write here plot.scatter, and then x and then we will write c equals to y, c map equals to, here I will pass this radius, and then I will write here plot dot x label. So I am giving here the label for x-axis. So I will give here SCPL sepal length, and then I will plot and write y label. So I will write label for y, that is sepal width, and then I will give the title to our scatter plot. I will write here iris dataset, and at last I have to give the output. Let's run this now. So here you can see the scatter plot for our iris dataset, right? So as we got the scatter plot for our dataset, for next we have to normalize our data now. So let us write the codes for that. So we'll write here scalar equals to, we have imported what? Standard scalar. So I will write that here, standard scalar, and then x underscore scale equal to scalar dot fit transform, and I will pass x here. right? So there is a spelling mistake here. Transform. Let's run it again. So as we have normalized our data, next what we have to do is to find the distance matrix using Euclidean distance. So let's do that now. I will write here distance matrix equals to pdist underscore x scaled and comma, I will pass here matrix. Metric equals to, we are using Euclidean, so I will pass that here. And then we have to convert the distance matrix to a square form matrix. So we will do that. I will write here condensed distance underscore matrix equals to square form underscore distance matrix. Let us run this now. Okay. So now we have to do the linkage matrix. So let us do that now. I will write here linkage matrix equals to, and we'll write here linkage, and I will pass here condensed distance matrix, and then we will write here method equals to what, right? Let's run this. Okay, and now we will create a dendrogram, right? So we have to plot that. We will write plot.figure and we'll give here figure size equals to 10,6, and then we will write dendrogram. I will pass the linkage matrix here, linkage underscore matrix, comma labels. So I have to pass the target here. And then we will give the title to our dendrogram. I will write here dendrogram of iris dataset, right? And then we will plot this. So I will write plot.show. So let's run this now. Okay, there is an error, figure size. Okay, so it's just FIG and size. So as you can see now, we got our dendrogram for this iris dataset, right? So you can see we plotted our dendrogram for this iris dataset. Okay, so this. So let me do one thing. Let me give a small size for this. I will write 8,4. Okay, now you can see it clearly. Okay, now you can see it clearly, right? So this is the final output of the hierarchical clustering that we have done in this iris data set, right? So that's all we have for this video. I hope you got a good understanding about what is hierarchical clustering, how it actually works, the types of hierarchical clustering, that is agglomerative clustering or be it divisive clustering, and how to do the implementation of hierarchical clustering using the scikit-learn library. So I hope you got a good understanding about all of this. So thanks for staying with us till the end, and if you found this video helpful, Please share it with your fellow mates and do subscribe to our Intellipaat YouTube channel so that you won't miss any updates coming from our side.
Just a quick info guys, Intellipaat offers machine learning course in collaboration with IITM Pravartak. Through this course, you will learn various algorithms and machine learning techniques such as supervised, unsupervised learning, natural language processing and much more from the IIT Madras faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel whose link is given below in the description. Without a doubt, this course can set your career to new heights. So visit the course page given below in the description and take a first step towards career growth in the field of machine learning.